Welcome to class today. In today's class, we're going to be looking at square and square roots of numbers. Square and square root of numbers. So quickly, let's define the square of a number. The square of a number is the number we get when we multiply a number by itself. So when we multiply a number by itself, that result we get is called the square of the initial number. Take for example, if we are asked what's the square of 2, that means multiply 2 by itself, 2 times 2. If we multiply 2 by itself, what we get is 4. So the square of 2 is 4. In the same way, the square of 3 means 3 times 3. And 3 times 3 gives us 9. So the square of 3 is 9. So the definition of the square of a number is the number we get when we multiply a number by itself. That gives us the square of a number. Okay, so here is a chart of the squares of numbers from 1 to 30. So as you can see, the square of 1 is 1 because 1 times 1 is 1. The square of 2 is 4 because 2 times 2 is 4. The square of 3 is 9 because 3 times 3 is 9. Okay, so when we write square in mathematics, we put a small 2 above the letter. So take for instance, if we want to write the square of 5, we're going to write 5 and then put a small 2 above 5. Okay, that 2 signifies square. So 5 squared means 5 times 5. 6 squared means 6 times 6. 7 squared means 7 times 7. So anytime you see this small 2 on top of a number, it means the square of that number. So it's telling you to multiply that number by itself. Now the square of a number is also called perfect square. So if you're asked what is perfect square, a perfect square is the same thing as the square of a number. Okay, so when a number can multiply itself to give us another number, that other number which we have already defined as a square is also called a perfect square. So in other words, a perfect square is a number that can be written as product of the same factors. Any number that can be written as product of the same factors is called a perfect square. So take for instance, as we have here already, 9 is 3 times 3. We can write 9 as product of the same numbers, 3 and 3. So which means 9 is a perfect square. We can also write 4 as a product of the same numbers, which is the 2 and 2 times 2. So 4 is a perfect square. So we can call it the square of a number. We can call it a perfect square. So all these numbers 1, 4, 9, 16, 25, 36, 49, and so on up to 900, which is the square of 30, they are all perfect square. They are also called perfect squares. So let's take a few examples. In example 1, we have example 1. The square of 17 is so we're asked to find the square of 17. The square of 17 means 17 squared, and that is the same as saying 17 times 17. So one thing we can do here, you can just look at the table that we already have. Look at your table. I've asked you to write down this table. Look at your table. The square of 17 is 289. The square of 17 is 289. If you don't want to look at the table, you can simply multiply 17 just like you know how to multiply 17 by 17. And if we do this multiplication, 7 times 7 is 49. Write 9 and you carry 4. 7 times 1 is 7 plus 4. We have 11. 1 times 7 is 7. We begin at the 10th place. So we have 7. 1 times 1 is 1. Remember, after multiplying, we'll add. So 9 plus 0 is 9, 1 plus 7 is 8, and 1 plus 1 is 2. So you can see we have 2, 8, 9. But I will suggest you use the table so you master while practicing or while learning. This is not exam where you will not be allowed to use to look at the table. So the more you look at the table, the more your brain memorizes some of those squares. So you will not need to solve the multiplication before you find the answer. So for now that we're learning, please look at the table. Okay, so the square of 17 is 289. So question 2, example 2, what is the square of 12? What is the square of 12? So square of 12 means 12 raised to power 2, or 12 squared. 12 squared means 12 times 12. And 12 times 12 is 144. You can check that in the table, or you can perform the multiplication. Let's look at example 3. Example 3 says, simplify 7 squared minus 4 squared. 7 squared minus 4 squared. So from what we've seen so far, 7 squared means 7 times 7, and then 4 squared means 4 times 4. Okay, so what is 7 times 7? 7 times 7 is 49. 4 times 4 is 16. So all we need to do is to solve this subtraction problem. Okay, 9 minus 6 is 3. 4 minus 1 is 3. So what this means is that 7 times 7 minus 4 times 4 will give us 33. All right, so the next thing we're going to look at is square root. The opposite of square is square root. Okay, let's go back to the table of squares. If you look at the table of squares, you discover that 1 square is 1, 2 squared is 4, 3 squared is 9. Okay, if we want to go backwards by looking for a number that will multiply itself to give us another number. Okay, that number is called the square root of the number we're looking for. So take for instance, if we're asked to find the square root of 9, square root of 9 means what is that single number that will multiply itself to give us 9? What number will multiply itself? So we know that 9 is 3 times 3. So 3 will multiply itself to give us 9. What that means is that the square root of 9 is 3. Okay, the square root of a number is the number that will multiply itself to give us the original number. Okay, so if we ask what is the square root of 25, we know that 25 can be written as 5 times 5. So the square root of 25 is 5. Okay, so make sure that you write that number as product of the same factors. So the square root of a number is the opposite of the square. Okay, so if 4 squared gives us 25, it means that the square root of 25 is 4. Okay, a square root of a number is a number that can multiply itself to give us the original number, just like I've said before. So this table of squares can also be used as table for square roots by working backwards. Okay, so the symbol for square root is this. So this is a symbol for square root. Anytime we see this signifies the square root of a number. So if I write this and then I write 36, it means what is the square root of 36? And since we know that if 6 multiplies itself, we'll have 36, it means that the square root of 36 is 6. That number that will multiply itself to give us the original number. So let's take a few examples on square roots. I hope you're following. Okay, the square root of 64. We're looking for the square root of 64. Okay, 64. We know that if you have mastered your table already, we know that 64 is the same thing as 8 times 8. So if 8 times 8 gives us 64, it means that square root of 64 will be equal to 8. That number that will multiply itself to give us the original number. That is the square root of the number. Okay, let's take another example. In this example, we're asked to find the square root of 121. The square root of 121. We know that 121 can be written as 11 times 11. So what that means is that the square root of 121 will be equal to 11. You see how simple that is? If we know the square of a number, it's very easy to know the square root of the other number. Okay, square and square roots are inverse. They are opposites. So when we walk from square to square root, we can walk backward from square root to square. Okay, so let's proceed. In this example, we're asked to find the square root of 25 over 64. So we're asked to find the square root of 25 over 64. So this is a fraction, but don't worry, it's also very simple. So what this means is that we're looking for the square root of 25 divided by the square root of 64. You can see that this square root symbol starts from the numerator and covers up to the denominator. So you're going to find the square root of 25, and we're also going to find the square root of 64. We know that 25 can be written as 5 times 5, which means that the square root of 25 is 5. And from the examples we've done so far, we know that 64 can be written as 8 times 8, which means that the square root of 64 is 8. So that means that the square root of 25 over 64, if we take the square root of 25, we have 5. If we take the square root of 64, we have 8. So square root of 25 over 64 is the same thing, or is equal to 5 over 8. Alright, certain times the fractions might be given as mixed fraction. Let's take the example. Find the square root of 2 whole numbers 7 over 9. Find the square root of 2 whole numbers 7 over 9. 2 whole numbers 7 over 9. To do this, first of all, we convert this mixed fraction to improper fraction. So 9 times 2 gives us 18. 18 plus 7 gives us 25. So 2 whole number 7 over 9 is the same thing as 25 over 9 if we convert it to an improper fraction. So the square root of 2 whole number 7 over 9 is now the same thing as the square root of 25 over 9 as an improper fraction. So just like we did in the previous example, we know that 5 times 5 is 25, which means that the square root of 25 is 5. And we know that 3 times 3 gives us 9, which means that the square root of 9 is 3. So the square root of two whole numbers 7 over 5 is the same thing as 5 over 3. Of course, we can also put this 5 over 3 back to a mixed fraction. So if 5 is divided by 3, it goes 1 1, and the remainder is 2. Remember, that remainder will be written as the numerator all over 3. Okay, so let's proceed. I hope you understand square and how to find square root. They're very simple. You can go back to the beginning of the video, or go to the point where you don't understand and repeat the video until you understand. Okay,